Have you ever wondered how the goodness of fit of a linear regression model is measured? Well, two key measures often used are sums of squares and R-squared. And what are sums of squares, you ask? They are tools used to quantify the amount of variation in the dependent variable that the independent variable explains. There are three types of sums of squares. Firstly, the regression sum of squares, often abbreviated as SSR. This measures the amount of variation in the dependent variable that the regression model explains. Secondly, the residual sum of squares, or RSS. This one quantifies the amount of variation in the dependent variable that the regression model doesn't explain. Finally, the total sum of squares, shortened to SST. This sums up the total amount of variation in the dependent variable. Now onto R-squared. This is a proportion that measures the percentage of the variation in the dependent variable that the independent variable explains. It's calculated as the SSR divided by the SST. Its value can range from 0 to 1. A value of 0 means no explanatory power, and a value of 1 implies perfect explanatory power. A higher value of R-squared indicates a better fit of the regression model. But how to interpret these sums of squares and R-squared? Well, a large SSR suggests that the regression model can explain a significant amount of the variation in the dependent variable. A small RSS, on the other hand, shows that the regression model can make accurate predictions of the dependent variable. And a high R-squared value close to 1 indicates a good fit of the regression model to the data. However, these measures have their limitations. They are only meaningful if the independent variable is truly related to the dependent variable. If there's no relationship, the sums of squares and R-squared will be falsely inflated. Plus, they can be sensitive to outliers. If there are outliers in the data, these measures may not be reliable. There are also other measures of goodness of fit that can be used to evaluate linear regression models. These include adjusted R-squared root mean squared error, or RMS, and mean absolute error, or MEI. To recap, sums of squares and R-squared are important tools used to measure the goodness of fit of a linear regression model. They quantify the amount of variation in the dependent variable that the independent variable explains. While they are useful, they also have their limitations, and other measures may be used alongside them for a more comprehensive evaluation of a model's fit.